Welcome back, guys. Uh, in today's lecture, we'll be talking about drawing logic circuits using min and max terms. We kind of talked about min and max term last time, so let's try to brush up that memories. What is a max term and what is a min term? We earlier talked about the sum of product or SOP, which is in this case, for example, will be A ended with B, or A ended with B naught, or A naught ended with B equal to Y. This is a sum of product here, and this is also called in engineering and scientist and in our textbooks when we go to colleges, they call this thing as a min term, which is sum of products. Min term is usually production, sum of production. So this is a min terms. Min term is usually sum of products. What is max term now? So now we will talk about that product of sum. The product of sum, or POS. So this is the product of sum. So that will be, if we have to use the same example, A or B ended with A or B naught ended with A naught or B gets the output Y. So this is a product of sum, and engineering and technician and scientists usually call this a max term. We would try to remember these things because we will be using these expression in the upcoming lectures. So we are heading to the next topics that we will be discussing will be simplifying Boolean expressions and then drawing a logic circuit using min and max terms. So that's why I brought up these two terms here. If somebody talk about min term, so remember min term will be sum of products and the max term will be a product of sum. So we usually just simplify these letters SOP and POS just to remember or make it easier for us to correlate what is what. So hopefully this is not that bad. We'll be in the next couple of lectures, we'll be using our experience from the past of the logic gates and implementing and to draw a logic circuit using these min and max term. We'll work on that too. Now since we know what a min term and max term is, let's see. Suppose we are given a Boolean expression of A ORed with B, that is ORed with C, and that term is ended with A naught ORed B, and that give us output. Let's call it M. It's asked to draw a logic circuit using this max term. We say max term is a product of sum, or we can just write it down in a parentheses POS, product of sum. So draw a logic circuit using a max term or this Boolean expression. Okay, so there are two steps to it. One step will be, we have a two terms ANDed together. Two terms ANDed. Step 2 is, let's write it down, step 1 and step 2 is we have a two OR gates. Let's call it A. A is ORed A ORed B, and that is ORed with C, and B is A naught is ORed with B. So these are the conditions here. These are the simplification of that. And just to draw this logic circuit, we'll have to find out how many logic gates are there. So we will see there we have two AND gates, and we have two OR gates, and we have one NOT gate. So keep these things in mind. We can draw a logic circuit. So what we will do, we will do it simply because our end product is an AND gate. So we will make an AND gate in the end right here. So that is my AND gate with output M. We know we have two terms, term 1, term 2. And so we will draw two input because that two AND gate, I think I got mistaken here. So only we need one AND gate here. We need two input, one AND gate. It's not a one AND gate, two input, one AND gate. Okay, so two OR gates, that's correct. So we need a two input, we will call that AND2. Now we will go to the second part of that. It's two OR gates. Let's change the color here. So okay, OR gate 1. OR gate 1 has three inputs. Input A, input B, input C. Output for that will be A, ORed B, ORed C. Now we have another OR gate. Which is with two inputs. Call that OR2. This is also OR. This is OR3 actually. Sorry. See, that's what happened when you change the color right before the time. This is OR3. Okay, so OR2 has two inputs coming into it. One is input A naught. To get A naught from A, this is A here. We will have to draw an inverter. We will have to use an inverter. So it was A, using the inverter made it A naught, and the second input is B. So output for that OR gate will be A naught ORed with B. Okay, so now we can connect these to go to that input part of that AND gate, and that will complete my logic circuit. So our task given was to draw a logic circuit using this max term, A ORed with B, that is ORed with C, and that altogether that term is ANDed with A not ORed B. So A or B or C, this term, ANDed, we use the ANDed as a final product, as an AND, that's how we call it as a max term, with the A not and A not ORed with B. So this and that, input 1 and input 2, they both should be on in order to have the output M on. Output M is only on if input 1 and 2 are both on or logic high. So if either one of these is off, this will never come on. But to turn on this OR 3 logic gate, it doesn't matter what input is on, either A on, B, C, any of these three input will make this output, let's call this output M1 for instance, and let's call this output M2. To have M1 on, you'll have to have A, B, C, or all three on, or two of them are, so any combination of them should be on. The only way this M1 will be off when all these three inputs are off. Same goes with M2 or this or 2 output. Or 2 output will be on when any input to this point, to this logic OR gate is on. If the only condition that OR gate output is off when both of them are off. It will be kind of confusing here, because if this input A is off, for instance, A not will be, so it will be inverting that. So if your switch is off, that will invert it to on, so your output will be on. So you just have to make that as a consideration. So what is asked and how is it dealing with. So that's how we draw a logic circuit using a max term. Let's move on to the min term. We will draw a logic circuit to a min term. Hopefully that example wasn't that hard. I'll try to be cleaner this time if I draw a new circuit. I'll move on to a next example. Alright, so we have a next example is using min term. Build a logic circuit. So this is our min term, or sum of product. We also call it min term. Sum of product or end product, our end result will be OR gate, the beginning. So we will have our last logic gate will be an OR gate. The beginning or the startup gate will be the AND gates. So let's draw. So how many? Let's see. We have 1, 2, 3, 3 input, 1 OR gate. That's what we need. We need 1, 2, 3, 3 AND gates. We need 2 NOT gates. So these are the specification of this Boolean expression of the min term. So to use this min term to draw this logic, draw a logic diagram or logic circuit here, we'll have to just, it will be easy if you write these things down, so we know what to look for. So we have 3 input OR gate, 3 AND gates, 2 inputs, and 2 NOT gates. Okay, so as we say, our end product was a OR gate. We will start up with a AND gates here. Change the color. So we have gate number 1, logic gate AND 1, so AND gate number 1, so we'll call it that and2 because it's 2 input. So we have 1 input here, 1 input there, so we have 2 input. One is input A, and input B. Let's call the output of that AND gate 1, call it for example A1. Now we have AND gate number 2. This is also AND2. So we have 2 inputs here also. Let's make sure what is A0. So we have an inverted signal, so that's this side is A. Coming out of that inverter will be A0, and this other input is B. Let's call that A2. Now the third logic AND gate is, that doesn't look like an AND gate. Okay, now it's better. So we still have 2 inputs here. Let's see, that's A, B not. A, let's invert that signal, so B not. And call this output of that AND gate A3. So we have 3 output already to go into the input side of that 3 input OR gate. So that's how we should be starting, because it'll be easier if you do it this way. So let's draw an OR gate. Okay, so we have a output Y is called for that OR gate, and we have 3 input OR gate, so pretty much all done. So we will just connect these output of these individual AND gates to the input side of the OR gate, and we will have our logic circuit ready. So A1, A2, A3 is going into OR3 logic gate. So to have output Y on, either A1, A2, and A3 should be on, or all of them should be on, or any combination from them should be on. The only way that output Y will be 0 or off when all these 3 inputs are off to the OR gate. So remember, these inputs to the OR gate is coming from the output of the AND gates, individual AND gates, and that's how we go from there and draw the logic circuit. So today we talked about min terms, what is that, and max terms. Min term and max term. Min term is sum of product, and max term is product of sum, as we said right here. So sum of product, we call it min term, as we did this example. In min term, the final logic gate will be an OR gate. In the max term, the final logic gate will be an AND gate. And we draw a couple circuit using both min term and max terms. So hopefully this wasn't that bad. We will see you guys with next lecture will be the truth table and the Boolean expressions, and then after that we will be just shifting gears to simplify the Boolean expression. In some point of upcoming video we'll be using a K-map or Karnaugh map and De Morgan's theorem. Please practice these questions, and if you find it difficult or hard, if you don't know something that I missed, or if my handwriting is not right, anything that you are concerned, please ask in the comment section. And see you guys with the next lecture. Take care.